How do you determine if two figures are similar? You can even determine if 3 or 4 or 5 figures are similar, but we're just going to focus on 2. This is for chapter 7, section 2 out of your textbooks. Here's an example of how your notes should look and be set up to take notes from this video. We have already discussed when 2 or more figures are congruent, and now we're going to focus on when they're similar. For polygons to be similar, corresponding angles must be congruent, just like if polygons were congruent. But here's the difference. And the corresponding sides must be proportional. That's different. For congruent figures, they had to be congruent for the sides and for the angles. But for polygons to be similar, they have to have corresponding angles congruent, and they must have their corresponding sides be proportional. So why don't you go ahead and underline proportional? So what I mean, in other words, the sides must have lengths that form equivalent ratios, which is why you had to do chapter 7, section 1 before this, when we discussed ratios and proportions. Make sure you get this this picture written down in your notes as well. Congruent figures have the same size and shape. However, similar figures have the same shape, but not necessarily the same size. The two figures below are similar. They have the same shape, but not the same size. And notice that the sides are proportional to each other. That means that they're equivalent proportions or equivalent ratios. True proportions or equivalent ratios. Let's look at the two triangles we looked at earlier to see if they are similar. So here is the picture of them again. Are the corresponding angles in the two triangles congruent? So is angle A congruent to angle D? Yes, both 70 degrees. And is angle C congruent to angle F? Yes, 70 degrees. And since the base angles are the same, we can then conclude that these are two isosceles triangles. Now what we need to look at is, are the corresponding sides proportional? Do they form equivalent ratios? So a way to do that is to set up some ratios. So we're going to use 27 to 36 and then 18 to 24 because we're talking about the corresponding sides. And let's see if this is a true proportion. We do 27 over 36 because it's BC to EF. And this is equal to 18 to 24. Is it? Well, if we divide this one by 2 and 2, I will get 9 and 12. I can also reduce it further and get 3 over 4. And then for this one over here, I can divide the top and bottom by 9, and I would get 3/4. So yes, they are similar triangles since they have corresponding angles here and here, and they also have sides that are proportional. They form equivalent ratios. Just as we saw for variables in earlier proportions from the last section, we can solve for variables to find unknown sides in similar figures. So here we have two triangles, and we're going to see if they are similar we know they're similar, but we're going to try to find out the missing sides since we know for sure that they're similar triangles. So we will do x to 12 because they're corresponding sides, and we'll set that equal to 5 to 10ths. Then we'll cross multiply and get 10x equals 60, divide by 10, and x equals 6. So since we knew that they were similar triangles, we set up a proportion, and we're able to find out the missing side length. This comes in handy for many different situations. Let's determine if the two triangles are similar. So we have this one here, which is 10 over x, and then 6 to 12 to set up a proportion. And then we also want to take a look at the angles. So let's go set up the proportion. We got 10 over x equals 6 over 12. Another way to write this and still get the same answer, you could do x over 10 and 12 over 6. You would get the same exact thing. So we're going to multiply here and here, cross multiply. Go ahead and finish it on your own, and then play it when you're ready to follow along with me. Okay, and so x should be 20. There you go. And yes, they are. Let's take a look. Let's see if they are similar. We got this corresponding angles are congruent. These ones are congruent. And these ones are congruent. We found the value for x to make sure that the sides are also proportional to each other. So they are similar triangles. So I said that there's many uses for proportions. Here's one. What if you wanted to find the height of a tree? Well, in the diagram, we can use proportions to determine the height of this tree here. I'd like you to take a minute, think of a way that you can find two similar triangles to build a proportion and solve for the missing height of the tree. When you have your answer, go and play and follow along with me. Okay, so this is what your proportion should look like when you're trying to find the height of a tree. We have this large triangle, which is x and 28. So I'll draw a smaller picture for you. Here's x and 28. And then we have the smaller triangle, the smaller one, which is going to be 5 and 8. So to set proportion, I did x over 5 and then 28 over x. And solve for x, and you'll find the height of the tree. Go ahead and do that part on your own. Here we have two different shapes, one for the rectangular windows. Go ahead and try to solve this problem on your own and bring your work to class, and we'll discuss it as a group. And here's one more last example for you to try. This time we're trying to find the height of the buildings, knowing the height of the smaller building. Go ahead and practice this example on your own and bring your work to class, and we'll discuss it together.